Okay, in this video we're going to try a little function question using a graph. So in this question there's a function drawn here, and it's x cubed minus x squared minus 8x plus 12, and it's there in the red line curving around that x and y axis. Now the key part is it says use your graph to estimate the following questions. So we don't have to do much, factorizing or quadratic equations or division or anything like that. We just simply use the graph for these questions. So the first one, it says use your graph to estimate the roots. So the roots are the places where the function comes through that x-axis. You see one there and you see a root there. So for that first one, x is equal to, where's there now? That looks to me like it's minus 3. And another root, the other root would be over here, which is clearly 2. So that's the answer to the first one, the roots. Part 2, it says find the roots of the equation x cubed minus x squared minus 8x plus 12 when it's equal to 5. So a lot of people might miss that part, that crucial little part, when it's equal to 5. So what you need to do is you need to go to 5 on that y-axis. Let's zoom in there. You need to go to 5 and go across until you hit the function. I hit it there. And then go down and read your answer. Now where would that be? It's not quite minus 3. And it's a little bit more than minus 2.5, which would be there. That looks to be minus 2.75 to me. Now, we're still not finished because we have to go the other way until we hit the function. We hit it there and then down there. Where's that? That looks like 0.75 or even 0.8 we might go with there. They give you a bit of wiggle room, so you don't have to have it spot on because we're estimating. But yeah, it looks like 0.8, even 0.9 you can get away with there, I think. Keep going again, because this is a cubic function. It's going to hit the line 3 times. We hit it there, go down. And what do you get? You get 3.2. Now it's okay if you got slightly different answers than that. I'm using the computer image of the question, so you might be even more accurate when you're using the book. So the answers to 2 then, I have them written there in blue. The roots of the equation, and there they are there. Okay, so you'd say x is equal to minus 2.75, x is equal to 0.8, and x is equal to 3.2. So that's how you do all those ones. Now I'm going to rub out the marks that I made because I don't want them to be getting in the way of the next question. The next question is, find the values of x for which y is greater than 0. Where y is greater than 0. Okay. Where is the function greater than 0? So 0 is like the point there in the middle, right? When it's down here, when the function is down here, it's less than 0. Because of course all these numbers here are negative. They're all less than 0. So that question is asking you to pinpoint where is it greater than 0. So it's greater than 0 all along here, all along here, and all along here. It's above 0. So essentially, just to remind ourselves now, right? This is the part that's greater than 0. And this is the part that's less than 0. So if they ask you for the values of x for which y is greater than 0, you need to find in the function where is it in the green zone. And it's in the green zone all along here, all along here. Now, how do I write that? That's the thing that people get confused about. So, put X in the middle. Put a little arrow going to the left twice, either side of it. The function is greater than 0 from here, right? Because you can see it starts being greater than 0 there, and it finishes being greater than 0 up here. So from here, where is that? That's minus 3. So minus 3 to here. Where is that? That is 4. Okay? Now, you can do that. Some people would be even more exact, and they'd say, well, it's greater than 0 from minus 3 to 2. They'd write that. So I'd put X in the middle. From minus 3 to 2. And do the same again. 2 arrows going to the left. From 2 to 4. Okay, so they just broke it up. And why would they have broken it up like that? Well, they're not too sure here. Does it stay positive? Does it stay in the positive zone? I would think there's no need to do this. I think that you're fine with just that there, from minus 3 to 4. That's the part where the function is greater than 0. Now the last question, part 4. The range of values of x for which y is positive and decreasing. Now, to understand that question, you need to have a fair idea of what that means on an xy axis. If you have a function, so let's draw a function, just wiggling, waggling, woggling, like that. Where is it? Which is which? Well, first thing is the parts that are positive. Okay, so let's do it with red highlighter. Positive. Where is that function? Positive. It's positive when it's above the line, when it's above the 0, up in the positive part. Here it's positive, 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 positive. Stops being positive because it starts going down into the negative, the negative, the negative, and it starts being positive again. So positive is anything up here. This is all positive up along there. And then below that is where it's negative. It's negative. Any part of it that goes down there is negative. So here's negative. There's negative. That's all negative down there. So down that zone is the negative zone. And up there is the positive zone. Now, what about increasing or decreasing? Well, increasing, it's like a roller coaster. Where is it increasing? Okay, so it's increasing when it's going up, 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 up. It stops increasing there. So that's when it's increasing. Where else is it increasing? Well, it starts going down here. So it's decreasing to there. That's decreasing. Imagine you're on a roller coaster. When you're going up, it's increasing. When it's going down, it's decreasing. And then it starts increasing again. Right at the bottom. Right at the bottom part. That's when it starts increasing again. So, they're the different sections. But what if and let me do this with a very specific black highlighter now. What if I looked for, where is it positive, decreasing? So I used two words. I want you to find the positive decreasing part. Okay, well, it's positive in that red bit, but where is it positive decreasing? Well, here. From there to there. Don't go any further, because if you go further, you would go into the negative decreasing, negative increasing, positive increasing. None of that is what we were looking for. We were looking for just the positive decreasing part. So if we could relate this to this question that we're asked to find where it is positive and decreasing. Okay, I know that the positive bit, just rub out the lines that are there. I know that the positive bit is up along here, positive, 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 positive. But where is it positive decreasing? Okay, that's slightly different. Well, positive decreasing would start here and would continue there. And at that point, it stops going down. It stops decreasing and it starts going up again. So I don't include any part after that. So basically, it's that part there that I've just colored in blue. That's the positive decreasing part. Okay, now how do I write that? Well, it's very similar to the way I just answered the previous question. Where is it positive and decreasing? So put in your two arrows, going to the left. Where does it start being positive decreasing? It starts around about here. Where is that? Let's work our way down. And you read off the x-axis. This point here. It's a little bit more than -1, a little bit less than -1. It's -1.2, maybe. So from -1.2 to here, and that's clear 2. Those are the values, the range of values where x of x, where y is positive and decreasing. Okay. Let's have a look at this question. Associate each sketch below with one of the given equations, with one, so each one is linked to an equation. So there's basic rules here. In functions, if you have an x, it means the line is going up. If you have a negative x, it means the line is going down. If you have an x squared in the function, it means it's a smiley face. If you have a negative x squared in the function, it means it has an unhappy face. If you have an x cubed in the function, it means it is a snake. Okay, now those rules, those 5 rules, really help when these types of questions come up, because it helps you identify a function very quickly. First of all, let's look at A. It's unhappy face. And so to have that, we need a negative x squared in the function. So we have one of those. Well, we have one there, but that has an x cubed in it as well. So an x cubed, remember, will look like this here. So it's not going to be that one. That's gone. That has a negative x squared in it. It could be that one. Could be that one. And it's not going to be the other two, any of the other two, okay? Because it doesn't have a negative x squared in it. Now notice in B, it also has a negative unhappy face. So these two here, that one and that one, belong to A or B. And which is which will be decided based on the other piece of evidence that's in those little functions. It's the 1 and the x. We'll come back to that in a second. Now, the easiest one I suppose to do is this straight line one. It's going down, so it needs a negative x in it. And the only one with a negative x in it is that one. So that f is going to be y equals -3/4 x plus 3. Okay. Then we have a cubic one here and at the start, over here. That will be either D or C. Now, which is which? Okay, so